So good afternoon. I'm Alan Halakmi. I'm a Senior Manager of Solutions Architecture at Amazon Web Services. I support primarily public sector customers. And I work with customers to plan and to execute successful migrations into the cloud. So in this session, I'm going to show you how your organization can go all in on AWS and how hybrid IT architectures can help you get there. Using a 5-step recipe, I'm going to describe how you can reduce your risk, gain experience, and leverage the existing assets you have as you move into the cloud. So imagine running a business that's critical to the operation of global markets, US markets, and in turn, global markets. You receive up to 75 billion market events each day. Your data requirements for compute, for big data analytics are exploding. Your storage requirements are in excess of 20 petabytes. You can't just build a new system. You can't take a chance and try something new. You have significant investments in your on-prem infrastructure and in your employees. But your business needs cost-efficient, scalable infrastructure. You need the elasticity that the cloud provides to support your big data analytics needs. And so you carefully plan a hybrid strategy to migrate components of your infrastructure to the cloud piece by piece. And as you gain more confidence and more competence, you adopt higher-level AWS services to accelerate that migration. 2.5 years later, you finished your all-in big data migration. If this is your story, then you're FINRA. Let me give you another example. A plane's disappeared from radar, and the world is frantically trying to find it. Or a tsunami's inundated a coastline, and the first responders want to know where people are and how to get there. Or maybe there's a wildfire, and the firefighters need to know how to contain the fire, but they don't have visibility into exactly where the fire is. These are cases where Earth imagery is critical. Not only do these types of events occur without warning, when they do occur, the necessity of imagery is immediate. Lives hang in the balance, and you need the elasticity of cloud. You need a way to effectively share in real time your massive inventory of images, 6 billion square kilometers of imagery. But you have decades of investment in legacy, proprietary, and closed systems that support your constellation of satellites. It turns out you can't buy COTS products that operate satellite constellations. But you decide that you're going to go all in with AWS to support your geospatial big data needs and those of your customers. If this is your story, then your digital globe. So I'm going to make 3 claims about hybrid IT. But the summary is this. We believe that in the fullness of time, for the vast majority of customers and the vast majority of their workloads, you will be all in on AWS. So with that as a background, you shouldn't think of hybrid IT architectures as the goal. You should think of it in the context of a tool, a mechanism, a strategy for an eventual all-in migration. Now, AWS provides tools for hybrid IT architecture, some of which are obvious. So you can see we have the recently announced server migration service, database migration service, storage gateway. We have a great number of tools. You can get private line connectivity into AWS using AWS Direct Connect. We also have obvious and maybe less obvious offerings that you can leverage. So for example, we have AWS WAF. You can use that with CloudFront and begin moving maybe your static content into S3. Your customer experience is unchanged, but the issuance of static content is now coming out of an origin in S3, and the dynamic content is still coming from your on-prem infrastructure. So I want to propose a 5-step recipe for an all-in migration using hybrid IT architectures as your strategy. Now, I think at the high level, this is fairly simple. Your environment may not be. So it may become more complex in your particular situation. But we're going to step through these, and for the duration of this session, I'm going to have a scenario in which we're going to see a lot of how do you do that on the screen using the AWS console and AWS capabilities, services, functions, features. What I want you to think about as we're going through the presentation, because I won't have a tremendous amount of time through which to kind of discuss not only the technology, but the people and the processes that are involved in hybrid IT and in general in cloud migration strategies, keep in the back of your mind how the approach that I'm proposing here allows your investment in your on-prem IT to be maintained for the duration of the lifecycle of that equipment that you define. Could be depreciation life cycles or other considerations. And also, I want you to take note that every step we're building confidence and competence on the part of the administrators, the DevOps organization, whoever is responsible for this execution during the migration process. So keep that in the back of your mind as we proceed through. So here's the backstory. My company sells IoT buttons. Increasing customer volume is driving us to the cloud, and we have existing on-premises systems. Our IT organization is new to the cloud, but we have a desire to get there to support the growing business. So here's where we are today. I have a third-party DNS provider. I have an active passive load balancer on-prem. I have 2 web servers, master-slave database. On the left side, I have some developers, and on the right side, I have my internal IT infrastructure. I'm showing it here as Active Directory servers. So this is where we're starting. Step 1, deploy a hybrid IT. And what I mean by this is really the core IT services, connectivity, core IT services that you need for potentially authentication, authorization to applications in your infrastructure. What are the things that need to be in place for the most fundamental operations of your environment to occur? Now, this is a very low-risk activity, and it's going to allow you to build confidence and competence in your cloud migration. So here's what we're going to do. We're going to create a virtual private cloud. We're going to create public and private subnets across 2 availability zones, so you can see them there, A and B for both public and private subnets. We're going to build a VPC with a VPN connection back to my on-premises infrastructure. Now, this could just as easily be direct connect. It could be direct connect with a VPN backup. It could be 2 direct connects with a VPN backup. The point is you're getting connectivity. Then we're going to use Directory Services AD connector to extend our on-premises identity infrastructure, or Active Directory infrastructure, into the cloud. And on the basis of that, we'll launch workspaces. And those workspaces will be where my developers start to do their development. So from a risk perspective, all this is easy, relatively easy, and much of this is low risk. Establishing connectivity to your on-premises infrastructure, probably not high risk. Extending your AD infrastructure using Amazon Directory Services AD connector, probably not high risk. And using workspaces for your developers, also not high risk. And the best part is, if at some point your developer decides, you know what, this application isn't quite working right in the cloud yet, I need to roll back to my desktop, they close the workspaces client and they're on their desktop, right? So all low risk, building confidence and competence. So let's look at what that would look like. So I'm going to create an elastic IP address because I'm going to be using a NAT gateway for connectivity from my private subnet to the internet for downloading patches and whatnot. And then I'm going to use the VPC wizard to create the first half of my multi-AZ infrastructure. I'll be using the 10.10/16 network. And I should just note that this is totally television cooking show stuff, so instances are going to launch in 2 seconds and things like that. We're working on it, but we're not quite there yet on the 2-second launch. All right, so half of my infrastructure is set up. So now I'm going to go in and create the other 2 subnets. I want to have it in availability zone B. And so I'll go ahead and create my second public subnet. And I'll just call your attention to it because it'll be material later. My convention here is that public subnets are 11, 10, and 11, and the private subnets, I believe, are 20 and 21. All right, those are created. The next thing I need to do is make sure that these subnets are associated with the appropriate route tables. Route tables are associated with subnets. They tell the subnet traffic how it should be routing out of the subnet if it's going outside the VPC in particular. And so in this case, I want to make sure that I have routes through my NAT gateway for my private subnets. Select those two. And then I will explicitly associate my two public subnets with the route table containing my internet gateway. So there you see an internet gateway is the default route. And I'll select my two public subnets. OK, so the basics of the VPC are now set up. Next step, we need to connect to our on-premises infrastructure. So we'll build a VPN. So I'm going to create a customer gateway. This allows me to define the IP address of the appliance or the piece of equipment on-prem that is the endpoint for the VPN connection from AWS's perspective. So that's my customer gateway. I'm going to create, which I've actually pre-created, and then attach to my virtual private cloud a virtual private gateway. And then I'm going to define a VPN connection that connects my virtual private gateway on my VPC to the customer gateway on premises. Now, my on-premises infrastructure is at 10.0/16, so I'll put that in here. I'm going to use static routing. So now the VPN is in place. I need to download the configuration. Obviously, there's a pre-shared key for my VPN tunnel. I need to get that to my on-prem equipment. So I'll download that information, put the data into my on-prem infrastructure, whatever that VPN endpoint was. And then, with a refresh, I should have a tunnel. Of course, we recommend having 2 tunnels. For speed in the demo, I'm only showing 1. All right, so I have baseline connectivity, almost. My VPC needs to know how to get to the on-premises infrastructure, so I now need to add a route to my route tables, letting the VPC infrastructure know that that 10.0/16 infrastructure exists through my virtual private gateway. And so I'll add that to both of my route tables so that my public and private infrastructure can get to the on-premises equipment. All right. Next, Active Directory. So we're going to go to Directory Services. We're going to use our AD connector to extend our on-premises AD infrastructure into the cloud. And this is really simple, right? What's the DNS information? What's the NetBIOS name? I do have to provide some account information so that as workspaces are added into the environment, I can register them in Active Directory, place them in the appropriate OU, et cetera. DNS servers on-prem that are aware of the Active Directory infrastructure can point me to the appropriate domain controllers, et cetera. I'll put this in my VPC, and I want the AD connector endpoints to live in my private subnets. So I'll put it in 21 and 20. All right. AD connector is being created, and it's active. So now, next up, I want to launch workspaces and let my developers begin the process of developing in the cloud. So I need to register this directory with workspaces. Very simple process. Registers fairly quickly. And there are a series of options that you can configure on the directory once it's registered with workspaces. Things like, what's the target OU in my AD infrastructure where these things should go? Is there a particular security group I want to put around these workspaces? In this case, I have a default one I've created. Should these workspaces get public IP addresses, or do I want to force them, in this case, to use the NAT gateway? You can introduce multi-factor authentication if you so choose. And if you're not using always-on workspaces, you can also specify a maintenance schedule on which these basically hourly workspaces will come up to take maintenance. All right, so now I can actually launch a workspace, select the directory I just created, search the directory for my username. I guess I'll be the first developer. Standard bundle. I could encrypt both my boot drive, boot volume, I should say, and the data volume. In this case, I'm not, but you should. And then the workspace is launched. Now, there's a registration code that exists that is the means by which we identify the appropriate directory to connect you to when you're using our client. So I'll take that registration code, put that in the workspace's client, log in with my 80 credentials, and now I am in a workspace in the VPC that I've defined. And I have connectivity back to my on-premises infrastructure. So if I have code repositories, CI/CD tool set, tool chain, if I have operational capabilities that I need to get back to on-prem, the connectivity is in place. All right. Step 2. Integrate operational control. So this step in particular is likely to be one of the steps that takes you the longest. Now, I'm going to show it in about 15 minutes, but I promise you it will take you more than that. The summary notion here is, piece by piece, you want to move operational control of the environments, soon to be a cloud in an on-premises environment. You want to move the operational control into the cloud, right? Hybrid IT should be thought of as a strategy for all-in migration. When you get to all-in, you will be managing everything in the cloud. So we want to start the process of moving everything into the cloud in terms of how we manage and operate the environment. So this is how we'll do it. This is our infrastructure as it exists right now. So I'm going to add Simple System Manager onto my on-premises infrastructure. That's the little orangish glow dots that are now on my web servers. That allows me to access the EC2 Run Command, which I'll show in a little bit. Then I'm going to download the AWS CLI. And the AWS CLI will be used later on to install things like code deploy and Opsworks. Now, the AWS CLI requires you to have credentials configured. The way that we'll get the credentials onto the devices is I'll create a user. I'll put the user's credentials into Amazon S3 with the appropriate restrictions. I'll create a pre-signed URL with a time limit on it. And then I will pass that pre-signed URL through EC2 Run Command to the instances so they can pull down the credentials. Remember, these on-premises instances have no AWS credentials once that CLI is initially installed. If this were something that was running on EC2 and VPC, you could use instance roles that would give those instances access, for example, to S3. On-premises, I don't have instance roles. So somehow I need to get my credentials onto those systems so that I can take advantage of the AWS infrastructure, pull down agents, register with services. And so I will do that by passing the credentials using pre-signed URLs and leveraging S3. Then I'm going to put an app in my website app that I'm currently running into code deploy. I'm going to register my 2 on-premises systems as code deploy targets. And once that's done and I know the website's working, I'm going to start building my cloud infrastructure. And I'm going to do that using Opsworks. I'll create a stack in my VPC. That stack will leverage an ELB, an elastic load balancer. I'm using a classic load balancer in this example. And I'll launch 2 instances. I'll use code deploy to roll my code out on those 2 instances. And I'll just footnote here, Opsworks has the ability to do code deployments. The reason I'm using code deploy here is because as I went through the evolution, building confidence and competence, I started with my CI/CD toolchain, pipelines, code deploy, et cetera. And so I've already made an investment, if you will, in code deploy. So I don't want to change midstream. I want to have a unified operational environment. So I'm deploying on-prem now with code deploy. I'll deploy in the cloud with code deploy as well. Opsworks has other features that I'll be able to take advantage of, including user management, monitoring. And so I'll be using Opsworks for that on-prem. So that's what we're going to walk through now. First step, EC2 Run Command. If you haven't used this feature, it is awesome. Awesome, you have to use it. So on-prem environment, I'm going to install this on 2 instances. What's the expiry date? When is this no longer going to be valid? I'm going to get a code back, so I want to have an expiration on it. And I can give it a default instance name. Great. So I now get a code and an activation ID. And the way that you get EC2 Run Command to work is super simple. I log into my web server, and I do 3 things. Download the package for the SSM agent. register the instance through the SSM agent, and finally, start it in agent mode. And that's it. So now I have the ability to execute commands. I did this on both web servers. I'm only showing one. I have the ability to execute arbitrary commands on these systems from the AWS console. By the way, SSM is a very powerful tool. It does much more than just shell commands. But I leave it to you, our white papers and documentation in our videos, to become more familiar with SSM. So now I need to create an IAM user, because at some point I do need to register these on-prem instances with code deploy and Opsworks, and I need a user credential to do that. So there's my access key and my secret key. And I'm going to create a policy so that my on-premises instances, my web servers, can register with code deploy. So I'm going to define a custom policy, make just a couple tweaks here and there to lock down the security a bit. And once the policy is in place, I'm going to create my code deploy user, the actual credentials that I plan to use when I'm deploying. That user credential set I've created, I'm now going to take the role and associate it to the user. So I created the user, I created the policy. Those two things are now being associated. All right, so now I want to get my on-premises web servers into code deploy. I want them to be registered. So I'll go down, EC2 Run Command, actually execute a command using the shell script capability. I'm going to select my two on-premises infrastructure instances, You can see them listed there. And here's the command to download and install the AWS CLI. So with the click of a button, that command is going to get sent off to those two instances on premises. AWS CLI will be installed. Now, with the EC2 Run Command, you do have the ability to see some of the output. It's truncated. There are other ways to get the full kind of message set. But as this runs, I want to have some confidence that I completed successfully. So there's one of them that's popped to success. The second one, I'll take a look at the output from the command and just confirm that things look normal. And you can see it's inflating the package, so this all looks right to me. So I've kind of done step one in terms of getting the CLI installed. Step two, I need to get the credentials that were created for that user that I just created onto these instances so that they can actually be useful to the AWS CLI. So again, I'll select these instances. I'll provide some URLs with the pre-signed S3 targets. And now I have credentials installed on those two servers. OK? Now that I have credentials, I can actually start doing things of value, like registering with code deploy. Incidentally, all of this could have been done in a single script, I'm going through kind of 4 steps here. All this could have been done in a single script. I chose to break it up because I'm new to the cloud, and I want to go step by step, building confidence and competence in the tool set. All right, code deploy. How are we looking on that? I have one step left. Run this command to install the config file and start the agent. So one last run through on the EC2 Run Command. And I will have 2 on-premises web servers able to communicate and receive versioned updates of my application through code deploy. And again, I'll take a look at the output just to make sure nothing looks awry. That's what I expect to see. All right, so code deploy. I'm not going to show you the process of going through an initial deployment. Candidly, we don't have the time. But I will show you that I have my website app that is deployed. But first, I want to show you that I was successfully able to register these instances with code deploy. So if I look at on-premises instances, there they are. Now, code deploy operates using tags. It's one of the mechanisms that you can use for specifying targets for deployment. And so I'm going to add a tag to the on-premises instances so that as I deploy, I can target a deployment specifically to them if I so choose. So I'll give them a location tag, and I'll make them both on-premises as the location. All right, so I load up my application. I do a deployment. Now if I take a look, I can see that I have successful deployments to both of my instances with my website application. Now for the demo, I'm using an open source package. I'm using Magento. This is going to be an e-commerce application, as we discussed earlier. So go to the URL. There it is. Now, I used code deploy to deploy my application on an environment that already existed. So I didn't take an outage. I simply used code deploy to begin to manage the code deployment process. All right, now I want to build my in-cloud instance of my application. So I'm going to go to Opsworks and create a stack. Put that in the VPC. And because I want to use code deploy in EC2 Run Command, I've created a chef cookbook that has custom recipes for installing EC2 Run and for installing code deploy. So I'm going to provide the path in S3 to that custom cookbook. All right, the stack is there. So let's start to create the layers. So obviously, we're going to create some web servers. So we'll create a web layer. And as I mentioned, when these systems come up, I want EC2 Run Command and code deploy to be installed. So I'll go to the recipe section, and at the setup point in the lifecycle, I want to execute these two recipes to ensure that that happens. I mentioned that we're going to use a classic ELB. So I'll click there. Takes me back to the EC2 console so I can set up my ELB. Now, there are things that I'm not doing here that you should, like if you have an e-commerce platform, don't do it over HTTP. I'll put the ELB in our public subnets, select some security groups so that the ELB can communicate with my web servers when they come up. I'm setting some fairly aggressive health checks so that we don't have to wait too long to see these things come in service as we're going through the demo here. Add some tags. Been keeping track of locations, so I'll continue to do that. All right, so we create it, and we'll have a URL that describes the classic ELB. Very well. So Elastic Load Balancer is in place. We now need to create some web servers, right? So we'll go back. This is the ELB we're going to use. You can set behavior of the ELB in terms of connection draining. And for the purposes, candidly, of debugging, I've enabled public IP address allocation to systems launched in this layer. We'll create two instances. Now, I'm creating two instances. I'm going to create those instances across availability zone A and B in this region so that I can achieve the multi-AZ availability target that I have for my e-commerce application. I'm going to select Ubuntu 14. That's what I'm using on-prem. I want to keep those things consistent. Pick a size, pick a subnet, 2A for this one. The next one will be 2B. I want this to be basically an always-on EC2 instance, 24/7. Unfortunately, we don't have time in the session, but obviously you can create time-based scaling and load-based scaling inside of Opsworks, and I welcome you to read the documentation on how that's done. Very simple. Start our two web servers. They'll go through their lifecycle stages, setup, then configuration both. And in that process, particularly in this setup lifecycle stage, they'll receive EC2 Run and code deploy agents. All right, so now just want to verify that I actually have my instances running. Yep, there they are. And because I plan to deploy code to them, I do want to give them tags. Again, location tags. So I could elect instead to use Opsworks tags, but I want to be consistent here, and I'm putting a location in for both of them. Once we have the location tags in place, we're going to actually go back to code, deploy, and push our application out to these two instances that are being managed by Opsworks. So create a new deployment group based on tag. We'll call this our in-cloud deployment group based on the location tag equaling in-cloud. You can see the 2 instance IDs that are going to be part of that right now. All right, deployment IAM role. And now we're ready to actually do a deployment. So if I go and take my most current revision of the website, specify the deployment group I just created, my initial deployment. All right, now we're deploying out to that Opsworks layer for the web servers. Now, I have to deploy to both. Code deploy is going to deploy these sequentially. Series of lifecycle events here as well. You can see them on the left side. So it's going to go through a set of stages. Now, one thing I won't have time to kind of discuss in line with the presentation later is that as we begin to move data, where I'm pointing to for my data, databases and so forth, I'll be making changes in the installation scripts that I'm using with code deploy, taking advantage of basically hooks in the lifecycle. They'll be updating which database I'm pointing to. So there's an implied, later on in the presentation, an implied redeployment of the application. So as you see me kind of moving between databases in the application, what's happening behind the scenes is a deployment. All right, so the deployment is now done. I can see that I'm in service from the load balancer's perspective. Which means I should be able to go to that ELB URL. There's my website. Do a search, all looks good. Currently, the website, this in-cloud website, is pointing to the RDS instance. It's not an RDS instance, the on-premises database instance, and so it's going over the VPN to get this data. You can see I have monitoring. That's great. I want to have monitoring for my on-premises infrastructure as well. Again, I want to move the operational control into the cloud, and so as a last step, I'm going to take my on-premises infrastructure, I'm going to deploy the Opsworks agent and bring them into the fold so I have a unified console for managing the infrastructure, both in cloud and on-premises. All right, this process is fairly straightforward as well. I'm going to run a command on the CLI that's installed on each of the servers on-premises. I'm going to do that using the EC2 Run Command. One detail. It's not good practice to keep IAM users enabled that you never use. You don't use them, why would they be enabled? So I need to actually do 2 things to my IAM user. One, I need to give the user the ability to actually register with Opsworks, first and foremost. So I'm looking for my Opsworks register via CLI. There it is. But the other thing equally important is I need to re-enable the credentials. When I was done using the credentials after that first installation, I disabled them. It's great to have them on the box, but nobody's using them. They shouldn't be enabled. I'll re-enable them here so that I can do the deployment for the Opsworks agent on-prem. There's the command line I need to run. Copy it off. And I'll take this back over to the EC2 Run Command and push this out to those 2 instances. So are folks starting to see the value of EC2 Run Command? Like everything I'm doing is using EC2 Run Command. It's a very powerful capability. Select my 2 on-premises instances. Execute the command. And that's kind of it. These guys are now going to be registered with Opsworks. Again, I'm building a habit here. I want to check the logs, make sure everything looks good. I expect to have truncated output, but it does look correct. All right. So now from an Opsworks perspective, I'm starting to get monitoring information. I do want to create, however, a different layer in Opsworks for my on-premises gear, because it gives me the ability to assign different chef recipes, for example. So as I'm building maybe chef recipes for use on-premises, I may have different considerations in the way that those systems are configured, so I'm going to create a separate layer for that. There it is. And I need to add my instances into the layer. So now I'm getting the benefit of Opsworks with respect to monitoring, the ability to push chef recipes, et cetera. One of the other things that I get is the ability to do user management. So we use SSH. I want my app user to be able to get into all of my web servers. And so I can put in that user's public SSH key give them SSH access, save that off, and now the instances that are in this stack are going to allow this user to SSH in. And in fact, if I go back to my on-prem instance and look at what's happened in the logs, you can see it's synced to remote users. Operational control, move it to the cloud. That's your all-in target. This one step will not take you minutes. It will take you weeks and months, but it's a very critical step. Step 3, synchronize the data. Ultimately, you need to get your data into the cloud. Data is gravity. So how do you do that? Well, we have services that support that. Database migration service is one. But the challenge is, as our infrastructure currently exists, I have my web-based application going over a VPN to get to the database on premises. And that might be OK. Chances are, if you have any significant volume, that that's going to be latency that you don't want your customers to experience. And it's going to provide load on that VPN that, if it's over the internet, may have questionable itself latency characteristics, right? This is where you maybe want to use Direct Connect. We want to try and move the data stores so that they're local, so I have predictable performance for my databases. But that creates a problem. So take a look. This is our infrastructure as it exists right now. I want to use RDS. This is my target. This is my all-in goal. So I can use the database migration service to take the data that's being, basically the transactions that are being loaded from my on-premises infrastructure into my web-based Opsworks managed infrastructure. But the problem is, what do I do when a transaction comes in from my VPC-based, my AWS in-cloud infrastructure? Let's say I took an order and it came in through the VPC side of the house. And then that same user came back later, and they ended up in my on-premises set of equipment. And they did a query on their order status. That red order doesn't exist there. That's a problem. So it turns out I can use database migration service to migrate the data back on-prem as well. So now I have a copy of the same information going back. If you do this, this means that you have a read-only and a write-only database on-prem, and you have a unified singular database through RDS in the cloud. A couple of caveats. For the vast majority of customers, when it comes to database migration service, simple cutovers work fine. You have one-way data migration with continuous replication. You schedule an outage, and then you swing all of the traffic over, and you're done. Some of you may not be able to do that. If you can't take an outage, this pattern is one that you should consider. Things to be aware of. 1, key partitions. If you have an auto-incrementing row, right, you have a column, it's auto-incrementing, and now you have a row collision because the auto-incrementation point was the same both in the independent RDS database and into your on-premises database, you're going to have a unique key constraint. That's a problem. So understand how your application works deeply, because you'll have to deal with key partitioning. The other thing is you need to be aware that you're going to have propagation delay. So if somebody comes in through the web services side of the house, through the AWS side of the house to your VPC, they're going to be able to do a read after write on a transaction. I put a transaction in, let me see the status immediately available. If they come in through your on-premises gear, there's going to be delay where that transaction makes it up to RDS, and then DMS brings it back down to the read-only copy. Your application needs to understand that there's going to be propagation delay, and I'll show you how to handle it here. You need to be aware that there could be network partitions, and that can substantially affect certainly the way your on-premises infrastructure works. So what I would say is this. The pattern that I'm showing you here is a transitional pattern. It's a days, maybe weeks pattern. This is not a months or years pattern, but it can help you migrate without an outage. So let's see what that looks like. So I'll go to RDS. I'm going to create the RDS database that I'm going to use for my in-cloud infrastructure. Fairly straightforward. The first thing I'm going to do is define the subnets in which it will reside. Not surprisingly, I'm picking private subnets, so 20 and 21. All right. Now, I'm using MySQL on-prem, and so I'm going to continue to use MySQL in the cloud. You could use Aurora. It's a great product. For the purposes of the demo, I wanted to kind of simplify it for you so we're not doing any type of conversions. All right, I'm using MySQL. Fine. You'll notice I looped through Opsworks just so that I can show you that it can be a layer in Opsworks, which has implications to some of the work that you do with Chef downstream. Give it some storage, some database information, user ID, password, and that kind of thing. Select a VPC, not publicly accessible, and I'll give it some security group association so that my web servers that are running in AWS can actually talk to RDS. If this is going to be a production system, I highly suggest that you actually pick your backup windows and not just take the automatically selected versions. We will take advantage of that if you let us. And fairly quickly, we do have an RDS instance set up. This is a multi-AZ configuration, so I have a master slave. And again, television cooking show, your RDS instance will not launch in 10 seconds. But these are the steps. Creating, it'll go to backing up, and then it'll be complete. All right, so now I have the RDS instance, and I'm going to point my in-cloud stack to this RDS instance. In the background, what I'm not showing you is that there is a deployment that's happening through code deploy to cause that to occur. All right, so now we're going to use Database Migration Service. If you haven't used it, it's awesome, awesome. We also have a schema conversion tool. It's just phenomenal. It really is phenomenal. It's very easy to use. So put in our private subnets, because that's where the databases live, both on-premises and in the cloud. So I want my DMS instance itself to launch in the private infrastructure that I have in the cloud. So this is an instance. Now, we added a feature a few months back that allows you to have a highly available multi-AZ DMS implementation. If you're doing this for production workloads, you should absolutely be doing that. So here I'm setting up multi-AZ DMS. And while the system is being created, I'm going to define my endpoints. So clearly, my source is my on-prem database. I'll give it a 10.0 address. Username and password credentials to log in. And I'm actually going to test the endpoint. I want to make sure that that connectivity is in place, that the credentials are working as I expect. Test successfully. So now we're going to define the target. The target is my RDS instance. So there's that long URL, or that long, rather, host name, FQDN. And I'm going to do the same thing, specify the appropriate VPC, and test. All right? Last step, I need to actually create a task. The task is the activity by which the migration of data will occur, and then continuous data set updates will occur as well. I'm going to use my Magento schema. That's what I want to replicate. And then fairly quickly, DMS causes these two things to become synchronized. So now anything that goes in from a transaction perspective to my on-premises database is going to be visible to anybody that's coming through my AWS-based infrastructure. So let's see what a checkout looks like. So I'm on my on-premises infrastructure. Oh, by the way, if you have questions about this, that is my email address. If you thought it was awesome, and you want to send compliments on the presentation, that's my boss's phone number. All right, so something that I want to call your attention to. The order here starts with 1 and a bunch of zeros. It's going to be material later, so just recall that I mentioned it to you. So there it is. If I go to that ELB, classic ELB that's fronting my in-cloud infrastructure, by the time I can type in the data, it's there, right? So the replication is happening from on-premises to the cloud infrastructure. Okie dokie. So now, because I don't want to take an outage in my migration process, I'm going to go the other way. I bring up this web page because you should be aware that there are changes that are required to the parameters of a default RDS installation if it is going to be the source for DMS. So just be aware of it. It's well documented. What I've done behind the scenes is updated some MySQL parameters through the RDS parameters and option sets, and so just be aware. So with those changes in place, I'm now going to create the inverse, right? My source will be my RDS instance living in the AWS environment. Same credential set. I expect that since the replication is working one way, it'll test successfully the other. And similarly, I'll create the target for my on-premises database. Now, you recall that on-prem I had master-slave. So what I'm going to do is I'm going to put in the IP address of the slave server so that it can be the consolidated read-only database for my on-prem infrastructure. I basically had it sitting there not doing much except for waiting for a failure to occur. So I'll use that as my read-only data target. Go through the rest of the configuration data, test the connectivity, and then as a final step, create the task. And that task will, again, do a full data migration and then continuous data updates from my RDS-based instance to my on-premises database. All right, so the majority of the work here is actually now done. But there's one more thing that we kind of talked about, the whole notion of latency and propagation delay. So when I had the infrastructure set up where I was doing the transaction execution on premises, you saw that by the time I could get to my AWS cloud environment, the transaction was there. Now, what's going to happen if I go to my on-prem environment now, because it's doing a read to a read-only database that depends on the transaction going up to RDS and coming back down? How does that look? So here's the order. Oh, one more thing, sorry. The order ID here, starting with 1200, that's an order that I put in through my AWS-based infrastructure. The reason I'm noting it for you is because I talked earlier about key partitioning. All of my orders that originated from on-prem start with 100. Everything that started in AWS starts with 1200, so I don't have transactional collision. All right, so we're going to put in an order that's going to have to do a round trip. This is going to round trip, again, up to RDS and then back with DMS transiting the data to and fro. Now, I've updated the application so that it's going to send me an email. Most e-commerce folks do that, but it wasn't doing it earlier. So it's going to send me an email with my transaction ID. The interesting thing about the Magento is that while it is aware of what the transaction ID is going to be at the time I place the order, it still does a callback to the database to get the committed data on the transaction to return it. So notice I don't have an order ID here because I've made a small tweak to the application so that it actually doesn't look for the order ID. I get an email. By the time I get the email and put the order ID back in, and this portion is actually happening in real time relative to the recording, the data's there. So the latency in that round trip is actually fairly small. So I now have an ability to migrate my data, easy. Transition load. So now that I have the ability to have my data available in both locations, I want to start migrating load to AWS in a way where I can, again, build confidence and competence in the tools that I'm using to do it. This is my infrastructure as it stands right now. We're going to pop out the DNS provider I'm currently using. We're going to put in Route 53, and then we're going to, through wait, gradually migrate the traffic over to my AWS infrastructure and then go to 0 in terms of the traffic that's being funneled towards my on-premises infrastructure. So show you how that's done. Fairly straightforward. Go to Route 53. I'm going to create a public zone in Route 53. My awesome IoT.demo. And I'm going to use aliasing, which is the ability for me, among other things, to have DNS responses to Apex record queries. So I'm going to create a record. The first thing I need to do is I need a record that points to my load balancer on-prem. So I'll put in the IP address for the load balancer on-prem. And once that's done, I can use that record that I've just created to create an Apex alias. So if somebody goes to awesomeiot.demo, it will return with a weight of 100 this IP address, 52, 52, 130, 165. Now I'm also going to put in my load balancer, but I will give it a weight of 0 for the moment. So all of my traffic is going to be heading off to my on-prem gear. I see the name servers that I need to go to my registrar to go make updates so that things are actually going through F53. You see all the responses are there are 165. OK, so now let's go 90-10. Again, slow migration, building confidence, building competence in the tooling. And you can see every so often I'm getting the pair of Elastic Load Balancer IP addresses that are currently associated with that ELB back. So that seems to be working. I feel good about the way the application's performing. I haven't seen any issues. So we're going to go 50-50. And now I'm expecting basically statistically, every other record to be 165, and the others to be the 2 IP addresses for my ELB. And that seems to be the case as well. And at long last, I'm going to turn off DNS responses that point people to my on-premises infrastructure. And now you see that .165 address is no longer returned. Last step, decommission your on-premises environment. So before I run this animation, which really is clearly the best animation I've ever been able to put together, and that's not a joke, unfortunately, I did have up here a video clip from Office Space, so hopefully you'll get the reference, but I was told that we don't have licensing for it. So imagine 3 people in a field beating up a PC load letter printer. Decommission your on-premises environment, and this is what you have. So you've migrated using hybrid IT as a strategy to get to all-in. Next steps for you. Identify candidate workload. Establish your hybrid IT environment. Build confidence and competence with AWS services. This is not just a technology problem. Your business process has to accommodate it, and you have to invest in your people so that this can be successful. Unshackle yourself from your on-premises restrictions and enjoy AWS. Thank you.